For the case study, let's take a quick overview of the plant. The plant is a 20 mgd design flow facility with an average daily flow of 12.6 mgd for the last year. The plant is actually two treatment plants, with the north facility shown here constructed in the 1970s, and the south facility was built in 2000. This facility is an activated sludge facility with an anaerobic digester and cogeneration, and land reuse of the biosolids which it produces. The cogeneration plant was upgraded at the beginning of the Veolia water contract in 2005. To ensure the maximum return on investment, the city included both financial incentives and disincentives to keep our focus on it operational. To date, the initial focus as a critical system has yielded excellent operational uptime, currently over 95% for the first 2 years of operation. So of course, when the relative criticality evaluation began, we all thought we knew that the cogeneration system would be the most critical. Actually, it turned out that an upstream system to the cogenerator was much more critical. That is the gas conditioning system, which cleans the gas and removes the moisture to provide gas quality nearly equal to the distribution line natural gas. This clean gas has greatly extended the life of the cogenerator, which is exceeded by 6,000 hours the required $30,000 top-end rebuild, which was scheduled for 10,000 hours. The gas conditioning system achieved a high ranking because of its collateral damage potential and a single point of failure, the system blower. The results of the review was to investigate the blower replacement lead time, which was found to be 12 to 16 weeks, and to get one of these into the critical spares inventory. Additional benefits of completing a criticality analysis include an increased understanding of the cause and effect of failures. During a discussion, the group may discover key components and/or processes that require immediate attention, just like we found with the gas conditioning blower. The workshops can also provide a learning environment for staff members on the systems considered, and through the process, a written documentation of the tribal knowledge held in the heads of the supervisors can be obtained. In addition, as each system is reviewed, the asset list for the system may be reviewed to ensure that it is complete and up to date, making this process a great way to review the current CMMS asset listing. The real surprise for the Gresham relative criticality analysis was the importance of this green box. As you can see from the screenshot, the system that included this substation transformer ranked third among all assets. It was only outranked by two pump stations in the collection system that, if they failed, backed up sewage into a residence, one of which was the residence of the ex-mayor. So, what is so special about this substation? Well, during the workshop group discussions, it became clear that this substation was a single power feed to the old or northernmost plant. This portion of the plant is much lower and receives about 5 million gallons of sewage per day by gravity. Without power to this lower side of the facility, the treatment process would fail, and potential was that 5 million gallons per day would go to the Columbia River. There's an emergency backup generator, and the cogenerator can also feed power to this system. However, all of the power goes through a single 2,000 amp breaker, which is located just inside the door in the building. A catastrophic failure of the substation transformer could damage this breaker and leave half of the plant without power. The following short video shows just how catastrophic a transformer failure can be. Once the risk of the substation had been identified, we immediately began to look into the history to see how long it had been in service. According to what we could find, this transformer had been in operation for 33 years. Typically, substations are expected to have a 30 to 50 year life, so that was a bit of a concern. However, the most concerning problem was that from the limited records, this transformer had not been inspected or serviced in 33 years. The review team took immediate action. Portland General Electric was contacted to come out and to provide a full thermographic and oil inspection of the substation to determine the condition. We all could relax a bit when PGE told us that it was in good condition. Now the PGE inspection is scheduled annually. The green box is now secured and kept clean around the outside by the staff and is recognized as a very critical asset. In addition, PGE is providing a lease or own critical spares program where they guarantee to be able to replace the unit within 24 hours. With careful annual tracking and trending of the condition, a catastrophic failure, which is rare, can be predicted in advance. If you have questions on the use of relative criticality analysis or the case study in Gresham, please feel free to contact me using the email address shown. Thank you very much for your interest.